Hi, my name is Frederik Kerling and I am quantum expert and cybersecurity consultant at Atos. In these next few sessions, we will be discussing how our knowledge gaps about quantum are impacting how we look at business and our business cases, and how becoming more quantum native allows us to adopt more possible options for our future organizations in using quantum computing.
Welcome to this third session of Quantum in Business and Society. This time I'll provide you with some guidance about formulating problems in quantum language. We've seen so far in previous sessions that to make most use of quantum computing, we'll need to rethink from the start how we formulate our problems. How do we do this? Perhaps, why do we do this? As surely it's not just a business gimmick. Well, we will find out today. Admittingly, these topics will be cognitively very challenging and won't contain too much slides. But understanding it is key to easily formulate problems in quantum terms from the start. So take your time and perhaps pause the session here and there. Of course, it is not just a business gimmick, though it does start with the problem formulation at the conference table. Normally, the explanation involves quantum terms like Hilbert spaces, non-unitary transformations, the no-cloning theorem and how to violate it, quantum oracles, dark states, and dark quantum oracles. Though they sound really cool, you'd require to understand all of these in order to get the entire concept. This is too much for now, so let's look at it from a more simpler perspective. Most of you will be familiar with so-called classical logic. It is called like that because many different types of logic exist. Multi-valued logic, intuitionistic logic, fuzzy logic, quantum logic, and so on. Basically, mathematicians tend to think of new names whenever small changes occur. The same mathematicians aren't too happy about how quantum physicists have hijacked and contortioned it into something they can use. For now, it is important to understand the symbols in brackets. Two values of knowledge, true and false, and the empty set. As you can see in the lower left brackets, a perhaps unfamiliar symbol exists. This is a remnant from the constructivism of intuitionistic logic. In most logical formalisms, we lack the use of an empty logical value, a zero, or a true unknown. Why is this even important? Aren't all things not either true, false, or somewhere in between? Well, in short, no. There is a lot of debate about this between mathematicians and philosophers of how this exactly works, but as physicists we have to deal with the day-to-day reality of the experiment. And the experiments tell us that their outcome is dependent on how the situation was ordered or executed, and how it was created or constructed. To make matters worse, and you'll probably have to let this next part sink in for a while, we can then subsequently destroy knowledge of parts of this construction process and realize different states in the experimental outcome after the fact of them occurring. This creates an interesting understanding of exactly what time is. And for those of you who might worry, we do not in fact violate causality, but perhaps not in the way you are accustomed to. If you want to know more about it, you can look up the so-called quantum eraser, or the series of delayed choice experiments. To get back to simplified explanations, we'll use this simple image. Because we don't really have a symbol in logic for this, we'll abuse the commonly used abbreviation for the reduction ad absurdum, a logical step. This symbol basically means the absurdum. There are better fitting words for this, but sadly not in the English language. This is our logical zero, the we do not know what we do not know. On the right is your true and false. It is what I know, and it's either true or false or something in between. On the left is what I know that I do not know. This is still very valid knowledge. For example, if I lose a page in a book, I might have lost what I know, but I know something is missing, and, more detailed, I know exactly what I do not know, namely one page of text. Knowing what I do not know puts heavy constraints on my knowledge of what I can know. That single page won't magically contain a whole new chapter with new knowledge, for instance. As humans, we are very accustomed about knowing what we do not know. For instance, I know I have a dentist appointment soon, but I don't know exactly when. I know my yearly results are good, but I don't know exactly how good. I know my employees are 8 hours in the office each day, but I don't know how many hours of that they actually do work, etc. So, what does that mean for formulating problems? Well, firstly, there is this thing, I know. These are relevant today now too, and there isn't a single company that doesn't know how to use them. Secondly, there is the newer things that I know that I don't know. When formulating your problem, it is important to use that too. A good brainstorm session often helps, and you can build the understanding about these things over a matter of time. Then thirdly, there is the great unknown. For now, leave that to the quantum programmers, as it's more of a tool than a part of the problem formulation. As a final hint, familiarize yourself with known knowns and known unknowns. It might seem complicated now, but it is a good first step towards being more quantum native. Over time, the world will change to be more supportive about adopting quantum computing, and we should familiarize ourselves with the future set of possibilities that become available to our organizations. Furthermore, there is no complicated math required to understand it. It is just conceptual, so you'll have little excuse of wanting to ignore it. Now, though I do not expect too many new markets from occurring, it will change how we look at these markets. This opens up new solution applications that provide new and better solutions to existing problems in entirely different ways as we did before. In the end, it might turn out that quantum computers' biggest impact is not their number crunching capacity, but more their ability to allow us to compute more easily with known unknowns. Now, to summarize what we have discussed so far. Firstly, you should familiarize yourself with known knowns and known unknowns. For instance, you should find daily life examples for them. Secondly, prepare your client interactions with client-specific known unknowns, examples they are familiar with. If you plan a specific workshop for a specific problem, also prepare some known unknowns as example that are relevant for the problem at hand. In your sessions, steer towards discovering new known unknowns, because a lot of them will be unknown to you but very known to the client. Fifthly, finish the session with a clear and desired solution format. You might have gathered a lot of known unknowns. If they do not contribute to the final solution, even conceptually, they are not much use to you. And then finally, consider how you can use them at your own time and see if you can get a follow-up quantum use case formulation workshop where there are more people present that actually know what to do with these kind of knowledge boundaries. All in all, I would like to thank you for watching these series. And if you want to know more, feel free to read up on the content available on the Atos blog pages, as lots of material is in there too. Alternatively, you can become a master student at the University of Amsterdam.